All right, example 6 here has us writing expressions in quadratic form. So if we look at this based off my rule from the previous video, we can see that we have powers of x that are a multiple of 2 apart from another. 10 times 2 is 20. So we get a situation that we can, if possible, yes, it is possible, in this one to turn it into quadratic form, which means that x to the 10th is going to be our u. Okay, our u is going to be x to the 10th, which means that u squared would be x to the 20th. Okay, so what can we do here? Well, we can say that we have, I think we have 2u squared, right? Because the 2 squared gives me the 4. The u squared is my x to the 20th. So 2x to the 20th, 2u squared. Yep. Plus x, 6x to the 10th. Well, that is going to be, based off the example they're giving us here, it's going to be 3 times 2x to the 10th. And then our last one is going to remain 15. That's not going to change at all. Okay. Not really sure why they wrote that in already. That is what I would have put in terms of u, but maybe they're saving that for the example B and C. Let's take a look. Let's take a look at what they show below. So on B, we have 18x to the 4th, 180x to the 8th. Okay, so our u, paying attention, should be x to the 4th. It should be our smaller one. And our u squared would be x to the 8th. All right, so what do we have? We've got, if a polynomial is not already in standard form, rewrite it, then examine the terms, choose the expression equal to u. Yep, so we're going to rewrite it as to the 8th, to the 4th, and then minus 28th, just so that we're in descending order of powers. And we're going to say that this is equivalent to 5 times 6x to the 4th. So 5 times 6u squared. We have 3 times 6u. And at the end, we still just have our minus 28. Okay. Continuing onwards. On this one, yep, x to the 6th is not x squared squared, so the expression cannot be written in quadratic form. Okay, so the requirement is that, remember, our exponent are always multiplied by 2 to get from one to the next one. Let's check this out. What is the quadratic form of 10x to the 4th plus 100x to the 8th minus 9? Well, if I call x to the 4th my u, then I have 10u plus 100u squared minus 9. I could rearrange this into the standard descending order, so 100u squared plus 10u minus 9, and then I could take this and plug it into the quadratic formula. When I do that, so if I put this into a quadratic formula, let's say this was all set equal to 0, we're going to use our quadratic formula, you'll get some answer that's in terms of u. So you'll get like u equals, I'm just going to make something up, u equals 3. Well, if u was originally defined as x to the 4th, then we know that x to the 4th equals 3. And we can do the 4th root of both of these, and we can say that x equals the 4th root of 3. Okay, so that would be the process. I'm not really showing that last step that I was describing, but that was me showing it, was that once you get this into your quadratic form, you can put your quadratic form into the quadratic formula to solve for u, just like we'd solve for x normally with the quadratic formula. And then you just take that u that you had replaced something with. You replaced, this guy, x to the fourth, and you reverse that replacement. You put x to the fourth back in there, and then you continue through to solve. Okay, this is a great way to simplify difficult scenarios. And it's just an interesting mathematical idea that you can take a hard problem and pretend it's an easier problem long enough to solve the easy problem, and then later take care of whatever that thing was that you kind of fudged. All right, that is it for example number 6.